Hi grade 11s. Today's lesson is based on the equation of a straight line. So let's start. There are different forms of a straight line, and we recognize a straight line by the highest power of the variable being 1. So here's the general form. Ax plus by plus c equal to 0. In other words, everything on the left hand side equal to 0 on one side. And usually a, b, and c are elements of the integers, z representing integers. In other words, a, b, c, normally it won't be like a half or any fraction. It will just be an element of the integers normally, unless otherwise stated. Then you get the standard form that we're very familiar with. This is also called the gradient y-intercept form, for obvious reasons, because in this form, in other words, when y is the subject, then the coefficient of x is the gradient and the constant is your y-intercept. So this standard form is very useful when we know the gradient, and of course if we've got the y-intercept, it's quite straightforward. We just substitute it to get the equation of our straight line. Then you get special lines, horizontal and vertical lines. A horizontal line, think of the horizon, there's no gradient. And then the equation of the line is just y equal to a constant. The gradient is equal to 0. Think of your desk or the floor. That's horizontal. And the gradient is 0. There is no slope. Well, there shouldn't be a slope, unless you have a special desk, of course. Then you get the vertical line. Here x is equal to a constant, so you have a line vertical. It will cut the x-axis, and all along that vertical line the x value will be the same. It's like your wall, it's vertical. The gradient is undefined. And then we come to another form. So you've seen all these formats before, somewhere either in algebra or somewhere along the line. You've seen, excuse the pun, you've seen those equations. So let's look at the one that we want to focus on today, and that's called the gradient point form. And this is the format. Y minus y1 is equal to mx minus x1. So when we have this little subscript here, it actually means they specific values. Okay. So in this form, well, the format of this line is very useful when you've got the gradient and you have a point. Then all you do is substitute. So m is still the gradient, and the x1 and the y1 is just the coordinates of the point on the straight line. So let's see how this works. Now, first example, it says determine the equation of the straight line parallel to y equal to 2x minus 3 and passing through the point 1 and minus 4. So the line we're looking for is parallel to that line and passing through the point 1 and minus 4. So let's remind ourselves about parallel lines. The moment the lines are parallel, we know that they have exactly the same gradient. So let's do A first. Determine the equation of the straight line. So we know that we need to use this format here. And what do we need? We need a gradient and we need a point on that line. So let's see. It's parallel to that line, which means our gradient is also 2. Remember, this is gradient y-intercept form. And we do have a point. So there's my x1. And there's my y1. There's my equation of my line. And all I do is I substitute. So we've got y minus, what's the value of y1? It is negative 4. What's the value of our gradient? It is 2. X, and what's the value of x1? 1. So it's x minus x1. And from there you've just got an equation. Then you're going to make y the subject. So minus times a minus is a positive. Multiply 2 times x is 2x. 2 times minus 2 is minus 2. And now make y the subject. Subtract 4 on both sides, and so we get 2x minus 6. And this is the equation of the line that is parallel to that and passing through the point 1 and minus 4. B says, determine the equation of the straight line perpendicular to this line and passing through that point there. Now let's remind ourselves about perpendicular. When we talk about perpendicular, we know that the product of the gradients is minus 1. So we're thinking of, if we're talking about product being minus 1, if the gradient of one line is 2, just want to draw on this. So if the product, if the gradient of the one line is 2, then the gradient of the other line must be minus a half to obtain a value of minus 1 in order for the lines to be perpendicular to each other. Here's another example. If the gradient of the one line is negative 4 over 3, the other line would have to be positive 3 over 4. So it gives me a value of minus 1. So remember, the product of the gradients must be minus 1 when we're talking about perpendicular lines. Let's come back to this here. Before we can find what our gradient is, we need to rewrite this so that we can clearly see what the gradient is. So we can make y the subject, subtract 2x on both sides, so we get minus 3y equal to minus 2x plus 7, divide both sides by negative 3, get 2/3 over x, 2/3 x minus, and 7 divided by negative 3 is negative 7 over 3. My gradient of this line is 2/3. Therefore, the gradient of the line which is perpendicular has to be negative 3 over 2. So now I have the gradient, it's negative 3 over 2. And I have a point, minus 4 and 3. So here's the gradient point form of the line, with x1 is minus 4 and y1 is 3. All I do is I substitute. y1 is 3, m is minus 3 over 2, and x1 is negative 4. Simplify, and a negative times a negative is a positive. So here we have, multiply the negative 3 over 2 times the x and times the 4, and we'll get negative 3 over 2x, negative 6. Add 3 on both sides, and the equation of the line which is perpendicular to the line that was given and passing through the point minus 4 over 3 is now equal to negative 3 over 2x minus 3. Let's look at example 2. Here they say determine the equation of the line, straight lines passing through the following pairs of points. Note, here we have points. We don't have information about the gradient. We just have the points. So the first thing we're going to do is we're going to determine the gradient. And we can use our gradient formula, y2 minus y1 over x2 minus x1. Here's my y2, here's my y1. Subtract them over the corresponding change in the x values, 1 minus minus 2, and if I work that out, I get a gradient of negative 4. So now I have the gradient of the line. Remember, we want the equation of the line, and so far I have a gradient and I have a point. So you can use any one of the 2 points now. And you use your gradient point form of the line, and all we do is substitute. So y1 is 3, m, the gradient, is negative 4, and x1 is negative 2. Had we used the other point, 1 and minus 9, your answer will be exactly the same for the equation of your line. And now we just simplify this, x plus 2 here in the brackets, multiply the negative 4 with each value inside of the bracket. That's why you get negative 4x, negative 8. Add 3 to both sides, and that is the equation of the line passing through those 2 points. Let's look at the next one. Here we have these 2 points, 1 and minus 3 and 4 and minus 3. Note, both of them have exactly the same y value. The x values differ, but the y value is the same. If I plot those 2 points, x is 1 and y is -3, x is 4 and y is -3, we'll see that those points lie on the same horizontal line. Y is constant. Y is equal to -3. It's a horizontal line, therefore that's the equation. Y is equal to -3. Note, the gradient is 0 and y remains -3 even though x is changing all along that line. Let's look at the next one. Determine the equation of the line passing through these 2 points. Notice here that the x values are the same, but y differs. So we have a vertical line. When the x values are the same, we have a vertical line. Let's plot those points. X is 2, y is 4. X is 2, y is -1. Note they lie on the same vertical line, cutting the x-axis at 2. X remains 2 all along that line. Therefore, the equation of that line is x equal to 2. Let's look at our last and final example. Unlike the previous examples, we have a sketch now. The sketch is given to us, but the question remains the same. Determine the equation of a straight line in this format. So let's see what we have. We have 2 points on that line. So for any straight line, I need a gradient and a point. I can use the gradient formula. Note the point is 0, 2. Remember here, x is 0 and y is 2. Here, x is 4 and y is 0. So I can work the gradient formula, 2 minus 0, changing the y, with the corresponding change in x, 0 minus 4, and then I'll get -1/2. Alternatively, just looking at this and using our knowledge of rise over run, the gradient is negative, and it's the vertical over the horizontal. So that's 2 over 4, which is 1/2, and we know the gradient is negative. You could have also just arrived at that answer without that there, -1/2. But note also I have the y-intercept, which is 2. It can be recognized here, but also you can recognize a y-intercept by x being 0. So all I have to do is substitute it into this formula, the gradient y-intercept formula. So the gradient is -1/2, the y-intercept is +2. That would have been the end of my story, but they ask me here how they want it in that format. So all you do is get rid of the fraction, multiply throughout by 2, and then write all the terms on the one side, and then equal to 0. So multiply by 2, get 2y minus x plus 4, multiply by 2. Transpose the terms, get x, positive x, get -4. So x plus 2y minus 4 equal to 0 is now the equation of my line in the format that they wanted. So note, these questions, they can give you 2 points, then you need to find the gradient first. Or they give you information about the gradient and a point. Alternatively, they can give you the sketch, and you can determine the equation of the line. We've used the gradient point form, but all of these could have been worked out just using y equal to mx plus c, which you've done in the past.